Okay, in this video I'd like to show some basic properties of an electric circuit. So at the very simplest level, a circuit is simply a kind of a closed loop of wires that connects a power supply to something it's powering. So I'm going to show you, this is the symbol used in circuits and schematics to show a battery or a power supply. Sometimes it's lots of alternating lines or whatever. This symbol comes from the very first battery, which was, or at least the first battery in the Western world, which was created by Alessandro Volta. And what he did was he took alternating metal, zinc, silver, or copper, zinc, or whatever it was, alternating sheets of metal, and spaced them out with blotter paper soaked with salt water or an acid, and found that one of the metals was more able to give up electrons. Another metal was ready to take away electrons, and so that oxidation reduction reaction led to a process where electrons would flow from one to the other. So in a circuit, we use that as the symbol for a battery. Here's another symbol. There's a switch there, and we'll have something simple here. We'll put a light bulb or a lamp there. So once you close the switch, electric current would flow through this circuit. Now, once you've got a circuit, you might start to measure things about that circuit. One thing you could measure is voltage. The battery provides the voltage. The voltage gets used up around the circuit. And anyway, so here's a voltage source, and here's where the voltage drop would take place across the light bulb. If there were a motor or a resistor or something else, that would be the place where voltage is dropping. You could have multiple batteries, and we'll see what happens when you have multiple light bulbs here. So there's voltage. When we have a circuit, we're going to have electric current flowing through. The symbol for current is I, and it's measured in amps. But anytime you have a circuit that is not a superconducting circuit, you're going to have resistance. In this circuit, there'll be a very small amount of resistance in the wires, but there'll be a substantial amount of resistance in the filament of this light bulb. So the resistance we write as R. Now this relationship we call Ohm's law. It's named after Georg Simon Ohm, and just tells us that the amount of current you're going to have is going to depend on the voltage and on the resistance. And since the current depends on volts and resistance, it's also common to see the equation written like this. More volts make more current, more resistance makes less current. While I'm at it, unit for voltage is volts. This is also called electric potential. The unit for resistance is ohms. By the way, we show that with the omega symbol from the Greek. And the unit for current is amps, short for amperes, named after another physicist. Was it Marie Ampere? I don't remember his first name, but Ampere was another physicist. So amps, volts, and ohms. I could have a 12-volt battery with a light bulb with 2 ohms of resistance, and I find that the amount of current, 12 over 2, I would get 6 amps flowing through this light bulb. Alright, well, there are other ways we can connect up things in a circuit. I can take that same battery, that same switch, and I'll put another light bulb right here. Now I have 2 lamps, and they share the same path. So every bit of current that passes by this lamp also passes by this lamp. Okay, this is called a series circuit. These components are connected in series. They share one path. And in series, we have a few basic rules. The resistance in series simply adds up. So whatever the resistances of these lamps are, I would add them up to find a total resistance. The electric current, though, however many amps flow out of this battery, those amps flow through this bulb and through this bulb. The current in this circuit is the same for everything. So the total current is equal to the current through this first object and this second component, and so on. And if there were 15 things all in series, they would all have the same current. And finally, the voltage used in a series circuit gets split. So if this is a 12-volt battery, this light bulb might get 6 of those volts, and this other light bulb would use the other 6 volts. There'd be a voltage drop of 6 here, and a voltage drop of 6 here, and a voltage gain of 12 in the battery. Alright, well, you can tell this is not a great way to wire things up. Certainly if I have a house and I want to put lots of electrical things connected up in my house, if my one switch turns everything on and turns everything off, that's not a very good way to run things. But also, if I add more and more of these bulbs, they each get less and less voltage, and so they would be quite dim after adding multiple light bulbs. So because of that, we don't wire things up that way. We wire things up in parallel. Now, series circuits exist. Certainly there are circuits where there's some resistance and then there's some component, and so you still need to understand how a series circuit works. But in our houses and in our cars, we wire up electrical components and appliances in parallel like this. So now my 12-volt battery provides 12 volts that get used up in this light bulb, and there's also 12 volts that get used up in this one. This is called a parallel circuit. These light bulbs are in parallel. Now in parallel, the resistance is a little bit different. Actually, the more paths you add in parallel, the less resistance you get. So if this was a 2 ohm resistor, and if this was a 2 ohm resistor or light bulb, if I add them in parallel, I actually get 1 ohm of resistance total for the circuit. So adding more in parallel causes the resistance to drop. The current, however, is not the same. Some of the current goes through this bulb, some of the current goes through this bulb. So the total current from the battery gets split. So if there are 6 amps, you would get, actually there'd be 12 amps now if this is a 12-volt battery, and if these are 2 ohms each. Now the resistance is 1, so I would have 12 amps. 6 of the amps would go through this one, 6 of the amps would go through this one. Okay? And now, so I see that the current gets split up, but the voltage is the same in all parts of the circuit that are in parallel. So if that's 12 volts, this gets 12 volts, and this gets 12 volts. So you can see why we use this kind of circuit in our houses and in our cars. By the way, if you were going to put a switch here, a switch to turn on this light bulb would go somewhere on this branch. A switch to turn on and off this light bulb would go on this branch. We often have circuits in which we put a fuse so that if there's too much current going to all these different components, the fuse would stop the current for the whole thing. It would be a safety feature. If you exceeded a certain number of amps in this main line, the fuse would melt or the circuit breaker would blow, and it would stop the current from flowing before some wire starts to melt somewhere. So those are some basic things about electric circuits.